When astronomers first began tracking the interstellar object, now known as 3I Atlas, nothing about its appearance suggested controversy. The earliest images showed a point of light so clean and sharply defined that it blended seamlessly into the star field behind it. There was no hazy envelope, no trailing plume, no sign of gas or dust being shed into space. Even as Atlas moved steadily inward toward the sun, its profile remained stubbornly unchanged. To the most sensitive telescopes ever built, it looked less like a comet and more like a silent fragment drifting untouched through the solar system. This absence of visible activity was not subtle. Hubble Space Telescope observations, capable of detecting extraordinarily faint traces of gas or dust, found nothing at all. Image after image confirmed the same conclusion. Atlas was compact, smooth, and featureless. In comet science, this alone was unusual. Objects of comparable size, following similar trajectories, typically respond dramatically to solar heating. As ice warms, jets erupt. Dust lifts from the surface. A glowing coma forms, expanding outward and announcing the object's volatile nature. Atlas did none of this. Throughout the summer, these images became a baseline, a visual record of how Atlas looked before anything strange was expected to happen. Researchers continued to monitor it closely, waiting for the inevitable transformation that never came. And while the object appeared visually calm, something far more troubling was unfolding in the numbers. Precise astrometric measurements soon revealed that Atlas was not exactly where gravity alone said it should be. By early November, the object had drifted several arcseconds away from its predicted position. At a distance of more than 200 million kilometers, that tiny angular shift translated into tens of thousands of kilometers of physical displacement in just a few weeks. This was not observational noise. The deviation was consistent, directional, and persistent. When the data were analyzed, the result was unmistakable. Atlas was experiencing a non-gravitational acceleration of roughly 0.02 of a millimeter per second squared. In everyday terms, that may sound negligible. In orbital mechanics, it is enormous. Sustained over a month, it is enough to move a 6-kilometer-wide object across distances comparable to the span between Earth and the Moon. Gravity could not explain it. The force had a clear radial component pushing outward from the Sun, and a lateral component nudging the object sideways. This is exactly the kind of signature astronomers expect when something is actively providing thrust. In comets, that thrust comes from outgassing, vaporized ice erupting from the surface like natural rocket engines. But here was the problem. Atlas showed no visible signs of doing that at all. On October 30th, Atlas reached perihelion, its closest approach to the Sun. This moment should have been decisive. Solar heating peaks. Activity typically surges. Yet Atlas passed perihelion unchanged. Still compact. Still sharp. Still silent. As it began its outbound journey, astronomers marked the next critical date on their calendars. December 19th, when Atlas would make its closest approach to Earth. At roughly 167 million miles, the object would still be safely distant, but close enough for unprecedented scrutiny. Space-based observatories and ground-based telescopes alike prepared to collect the most detailed data possible. This window represented the best chance to catch Atlas in the act, to finally see the gas or dust that could justify the mysterious push altering its course. After that, Atlas would continue outward toward Jupiter, encountering the giant planet's gravitational influence in early 2026 before exiting the solar system entirely. There was no danger to Earth, no risk of collision. What was at stake was understanding. The physics made the situation even more difficult to dismiss. To accelerate an object roughly 6 kilometers across by the measured amount requires a tremendous transfer of momentum. Estimates suggest Atlas has a mass of at least 30 billion tons. To generate the observed force through outgassing alone, it would need to lose more than 5 billion tons of material in a very short time. That is not a quiet process. Such mass loss would produce an enormous, brilliant coma, and a tail stretching millions of kilometers. Even modest telescopes would see it instantly. But nothing appeared. Spectra showed no strong emission lines. Images revealed no expanding halo. The sky remained blank. The math demanded a spectacle. The universe provided none. As observation campaigns intensified, the mystery deepened. Photometric data showed that Atlas's brightness did not increase like that of a normal comet. Instead of following a gentle curve, its brightness surged steeply, following a power law far more extreme than anything typically observed. Such rapid brightening is usually accompanied by explosive dust release. Yet again, no dust cloud emerged. Color measurements added another layer of strangeness. Near perihelion, Atlas shifted toward the blue end of the spectrum. Dust-rich comets tend to appear redder as sunlight scatters off fine particles. A blue shift suggests something entirely different, possibly gas emissions or an unusual surface reflectivity. But with no visible coma, neither explanation fit comfortably. By this point, anomalies were stacking up. Atlas arrived on a trajectory closely aligned with the plane of the solar system, statistically unlikely for an interstellar visitor. Reports hinted at a jet oriented toward the sun rather than away from it. Its size was larger than expected. Its speed was higher than models predicted. Chemical analyses suggested an unusually high nickel-to-iron ratio and an unexpected scarcity of water. Polarization measurements did not match known comet dust, and its arrival direction coincided with a region of the sky already famous for unexplained signals. Any one of these features might be dismissed. Together, they formed a pattern that refused to fade. Astrophysicist Avi Loeb has been one of the most prominent voices urging caution and clarity in interpreting the data. His position is often misunderstood. He does not claim to know what Atlas is. Instead, he insists on a disciplined approach. List the anomalies. Test each one. Ask whether existing models truly explain them without stretching assumptions beyond credibility. If an object accelerates without a visible coma, does outgassing still make sense? If jets point sunward, is there a known physical mechanism that produces that behavior? If mass loss at the required scale leaves no trace, what alternative explanations remain? These are not sensational questions. They are basic, scientific ones. Loeb emphasizes that science advances by setting clear, falsifiable criteria. In the case of Atlas, those criteria are straightforward. If a substantial coma appears during close Earth approach, if gas emission rates reach expected levels, if dust production matches the required mass loss, then the mystery resolves naturally. If not, then conventional comet physics cannot account for the observations. This is what makes Atlas such a rare case. The test is clean. By late January 2026, the data will be in. Either telescopes will detect unmistakable signs of outgassing, or they will not. There is no middle ground. The outcome matters far beyond a single object. It speaks to how science confronts the unknown, whether researchers are willing to follow evidence, even when it challenges comfort, whether anomalies are examined honestly or explained away by habit. As Atlas continues its silent journey through the solar system, the instruments watching it represent humanity's collective curiosity. Every photon collected, every spectrum analyzed, every deviation measured brings us closer to an answer. Not about danger, not about invasion, but about understanding the universe we inhabit. The real question Atlas poses is not what it is, but how we respond when nature refuses to behave as expected. In the coming weeks, the sky will decide. And when it does, the most important test will not be in the data alone, but in our willingness to listen.